name is Rona Davis. I am on the strategy and technology team at CommScope. I'm also a proud member of TIA SPEC. Thank you for joining us today for a panel discussion on building to 10 megabit single pair Ethernet. We hope you find the information helpful, and we will have a Q&A session at the end of the panel discussion. So go ahead and if you have any questions, go ahead and post them in the chat window. And we'll get to those at the end of the discussion. We have a distinguished panel here today to talk with you about single pair Ethernet. It's a fantastic topic, and it's a great technology with significant utility for our built spaces. I'd like to start by having each one of our panelists introduce themselves and give a brief overview of their current role and industry experience. Andy, why don't we start with you?
Yeah, thanks, Rona. Good morning, everybody. My name is Andy Jimenez. I'm with Anixter. I'm part of our technology strategy team here, based at our corporate office just outside of Chicago. So I'm responsible for really delivering new solutions to the market. I've spent the last 18 months or so developing on the program side different smart building programs to the market. So really been involved from a market point of view in developing solutions for intelligent buildings. I'm also part of TIA SPEC, as well as an active voting member on the TR42, as well as the IEEE 802.3 LMSC. So appreciate the opportunity to speak to everybody today. And I'll turn it over to Frank.
Thanks, Andy. My name is Frank Straka. I'm a product line manager at Panduit, and I specifically manage our enterprise connectivity products, which is primarily a lot of the copper products. I'm also involved within TIA SPEC and a voting member as well as TR42.7. Within my role at Panduit, I've really seen the advantages of, copper-based standardized technology, and I, really see it as a benefit to the industry, a benefit for innovation, and really just provides a lot of strong advantages to people that use, the standardized RJ45 interface to just connect just a wide range of technologies. And when I look at single pair Ethernet, I really see a new technology that's really just, on its first legs here. And we see it having the same advantages that the RJ45 gave to all those different devices, into some new areas. So I am excited to talk to everyone today about single pair Ethernet, and thank you for coming to this panel discussion. So Heath.
Thank you. Greetings, everyone. My name is Heath Stewart, and I am the design director for Power over Ethernet products at Analog Devices in Santa Barbara, California. My group drives both traditional Power over Ethernet design as well as the emerging single pair Power over Ethernet, which we will be discussing in more detail today. I really wanted to thank you for the invitation, Rana. It's really refreshing to be able to come together and discuss this exciting new technology, what it means for Bixby, what it means for the world of building automation. We're going to spend a lot of time today talking about it's a fragmented state of data and power protocols and building automation. The twin pillars of single pair Ethernet are data and power. And together these promise to bring edge-to-edge Ethernet, which was going to marry the IT and the OT worlds. Back to you, Ron.
All right, thank you. Thank you so much. So we're just going to have a quick pause here for an important notice, one of our disclaimers. And let's get started. So we've all heard a lot about the data, right? I'm doing that in air quotes. But so getting access to the data, how do we secure the data? What do we do with the data? And then, of course, especially as of late, who's got my data? And in the current condition, I think we all have pretty strong feelings or ideas about the value of data, especially good data. But to set the conversation today, I want each of us on the call and all the listeners here to think about what really is the value of data when it comes to the building. Why is it so important? I bet you probably didn't think that I was going to task you with some philosophical questions today, but behind every new technology and every new advancement, we really have to ask ourselves about its utility and whether or not the advancement does more good than harm, right? We spend most of our lives inside of buildings, and they're where we learn, where we work, invent, create, collaborate, love. It's where we get our fitness, where we eat, sleep, and buildings, most importantly, are where we connect with one another. Our buildings represent our humanity and at times our lack of it. My first question to each of the panelists is what their perspective is on the current state of building automation. And I'm gonna start this this question with Andy.
Yeah, I would say I would characterize it from a building automation perspective as really as a point of transition. If you look at the market, it's definitely evolving. The building automation space, if you look at it traditionally, is really reliant on traditional analog two-wire solutions to deliver the data and information that you just referred to the different applications and analytics that are within a building space. And for the most part, it works. But I think there's some advantages to you're going to an Ethernet or IP-based environment. So if you look at the trajectory of IP-based systems, it's again, at the danger of dating myself, when I started my career, it was 10 megabit per second operation from point A to point B. You could transmit the data across your corporate network fairly easily. And if you look at where we're at today, I mean, we're orders of magnitude higher data rates that we can achieve within buildings in terms of data transfer. But the other advantage that we've seen with the advent, and you just talked about it with PoE, we have the advantage now to also deliver power and data communications through a singular infrastructure. So from an Ethernet perspective, if you apply that to building automation, while automation works today in the current state, I think there's from a technical perspective to do some levels of integration and consolidate your wiring systems. So you're not having to use multiple wiring systems for power and different wiring systems for data communication. So really the net effect is that we'll have more and more devices that have been traditionally on what we call the facility side or the OT side of the house, kind of transitioning to the IT or IP side of the house. So there's this kind of facilities management, IT operations convergence that'll happen. And the net effect is really device growth. If you think about the number of devices that will be deployed over the next several decades, and this is a statistic here, 75 billion devices in the next 6 years. That presents tremendous opportunities, I think, for everybody in the ICT industry, but also presents challenges because you have to connect to those devices in some form or fashion. You have to manage the devices, and you also have to extract the data and information from those devices. So I think the building automation market, while slowly in transition, I think will kind of take advantage over what we've seen over the last several decades with IP communication. So I think more and more, as we kind of get into this more IoT-like environment, we'll see opportunities for Ethernet to grow in this environment just due to the device growth itself.
Yeah, I think that is a great insight, Andy, and you hit on a key point there, the ability to access the data easily, right? And so if Frank, on this next slide, Andy also hit on convergence and in the building and talking about the systems, being able to talk to each other. But Frank, in your perspective, how will these changes of these networks moving over to these operational technologies moving over to Ethernet technology, how will these changes change our approach in the building as we're preparing the infrastructure?
So that's a good question, Rona. There's a lot going into that question. So I'd say, if you kind of start where, convergence began, right, is just something simple like voice and data. I mean, right now, people don't even really think about the fact that most phones are going in, now are IP phones, right, running off of, say, power over Ethernet. And then now that most cameras going in are running over that same network infrastructure. So right now, though, when you're planning for all these other systems you've listed here, say AV, access control, lighting, all that, these can all run over a lot of different systems. So there's a lot of initial groundwork that needs to be done to get those systems to work. Right now, to do, say, voice and data and video surveillance, from a cabling physical infrastructure perspective, you're running the same 4-pair category 6A cables with RJ45 connectors that you're running, kind of all over the place to the desk to provide data, to provide, going out, say, an access point. So it's all that same infrastructure. Now you're just running it to more places, or maybe using that cabling infrastructure that already exists for different things. When you're looking at planning for a lot of these other devices, there can be a little bit more challenges involved there, because a lot of these systems, for one, could be very different cabling requirements, different, just different areas where they have to talk to each other. And so when you're looking at planning out that design, a lot of work needs to go into that. And, you might have a AV guy that needs to plan out the AV stuff. The lighting guy needs to plan out that. The HVAC guy needs to plan out his areas. They need to ensure that all the cabling runs into all the proper areas. Whereas, moving to something that's a little bit more standards based, a little bit more, say like something like single pair Ethernet, you'd be able to run that same cabling across the board to all these different devices. And so from a planning perspective on cabling infrastructure, it'll be a lot simpler, a lot more straightforward to do. Then in addition to the fact now that you're running all these systems over, an IP-based network, they're all going to naturally be able to talk a lot easier. And, the overall getting the systems to converge and work together and have that intelligence, for that data that we're all looking for, will be a lot more intuitive. I mean, I know from my perspective, say I switch a desk at Panduit, right? I can just take my phone out, unplug it from where it is, go to the new desk I'm at, plug the phone in, and I'm up and running. And that whole thing took about 30 seconds. So, just right off the bat, I mean, there's a lot of advantages to being on an IP network instead of all these almost proprietary based systems, which again, to Andy's point, have worked very well in the past, but with offering something that's IP based, standards based, will confer a lot of advantages to people. So.
Yeah, it does seem like those common design conventions that we have within Ethernet, if we could extend those to the other building systems through single pair Ethernet, it certainly seems like it would increase the speed of design and implementation, like really improve it, especially in design velocity. Sometimes you don't know what all these different systems are really going to be at the end. You've got sort of an RFP process, or you're working from design drawings, and those finals. Sometimes you don't know those final systems. So how can they, the engineering community really design around that? It's very difficult, and so it does seem like this would simplify that process, lower the costs of the design process, and make it faster. So that's great. That's great information, Frank. So the building automation market really has found themselves in this similar situation that Ethernet was in some years ago. Some of us on the phone were there for that. And it does, where, previously before there was a lot of different types of IT networks, right? And then everything moved over to Ethernet. And it seems like the building automation or the operational technology networks are in a similar space. Heath, can you share your thoughts on that evolution, the similarities to the IT networks history?
Absolutely. So I've been thinking and reading quite a bit about what made Ethernet so successful in the past. And my research led me to a book called The Triumph of the Ethernet by Urs von Berg. You see, back in the 1980s and the 1990s, there were a great number of competing IT network standards. And what the industry realized is that really an ecosystem of component vendors and system vendors sponsoring individuals to contribute to a truly open standards development process, this would have an enormous advantage in the marketplace. In essence, collaboration beats competition. So gone were the proprietary and the incompatible networks. No more were the disruptive bridges and gateways. And also there was no more worry about single source solutions. So why did Ethernet displace other protocols in the IT world? You know, it wasn't that Ethernet was always the best protocol for a given application, but it was the most open. It had the largest ecosystem of vendors, and it really represented the collaboration of that entire industry for the greater good. Thank you.
Okay, I wasn't sure if you had a little bit more there, so I was giving you time if you were just pausing, Heath. I think that those are some really excellent points and takeaways. Is that there probably were multiple, there's multiple options that were out there within Ethernet, and we centered around Ethernet because of the ability to, for deployment, for open communication. And I think within the IT industry, this is just it's come to be that this is how it needs to be, right? If we're going to progress. And I think that OT systems really, if they want to see the full benefit, if we want to have the full benefit of all of these different devices, we do need to have a common communications protocol, and I think that Ethernet has a proven track record. It has worked. Adoption is kind of the standard now, and we see how it has benefited the IT space. So that's great. Thank you for that, Heath. So we've kind of talked about our opinions about single pair Ethernet, but we actually should probably talk to you a little bit about what is single pair Ethernet, and before we get into too much more detail. And I'm going to have Andy kick off this part of our discussion on really what is single pair Ethernet.
Yeah, thanks, Rona. So as the name implies, it's a single pair. So it's just two wires versus the traditional four pair A-conductor cable that we're used to. So you're delivering much like we have in the past with four-pair systems, data and power services through a single pair of wires. And really the origins of the project was really just kind of this gap in Ethernet networking. So Heath talked about a lot of the advantages from protocol consolidation. So you're kind of using Ethernet as kind of the ubiquitous protocol to now deliver information across your different networks. So the advantage of single protocol is the ability to do high levels of integration. So you're not having to work with multiple protocols within whatever application environment that you're in. So if you look at, industrial automation, there's probably a dozen protocols that are out there today. If you look at building automation, probably half a dozen. So I think the advantage in Ethernet in that domain is to basically consolidate communications to a single protocol environment. But the gap that existed prior to this project was that copper-based twisted pair cabling was restricted to 100 meters in physical reach. So there was a desire to extend that distance to more of the field bus type of applications and the bus applications that we see today. So to contrast, there's field bus and bus solutions that extend upwards of 1,200 meters. And if you're only running copper-based communications by a twisted pair, four pair, you're going to be restricted to 100 meters. So the IEEE undertook the project a few years ago. A CFI, or call for interest, was established. The 802.3CG, which is the single pair Ethernet standard that was published by IEEE in 2019, really had two objectives. The first objective was the long reach. So they've got different reach requirements that are built into it. So there's 10 base T1L, which is more of the long reach solution, so really targeted to the automation spaces that we've talked about. They also have a T1S variant, which is more on the automotive side, which gives you a reach of up to like 15 meters. So really for that application environment, it's really targeted to that. So you've got the long reach and the short reach objectives in there, and you also have 10 megabit per second operation. And that's sufficient. You may ask yourself, I was talking about high bit rate, 10 gig and perhaps even 400 gig solutions that are out there today. But if you look at most control and field bus applications, they're not high data rate devices. They're consuming probably kilobits of information. So a 10 megabit per second link could really achieve that. So the project really, those are really kind of the two your key attributes of it: 10 megabit per second operation, up to 1 kilometer in distance. So really getting that, kind of those two criteria you put together. And the other thing too is we mentioned power over Ethernet. The ability to deliver power is also part of the standard as well. In parallel to that, TIA and the ISO committees are working on the connector and the cable specifications. So the IEEE work is done. The TIA work, which is being conducted by the TR 42.7 committee, they're developing the 568.5 specification, which is in ballot resolution phases right now. That I think that should be completed sometime this year. But the net of it is that you'll have a fully standardized environment, both at the physical layer as well as at the PHY layer. So you'll have a full ecosystem that will probably be deployed at least production levels, and I'll let my colleagues talk to that by the end of the year. But that's kind of the high level overview, and I think Frank and Heath are going to cover a little bit more on the connector types and the power distribution methods that are available.
Okay.
Andy, if I could jump in there a little bit, there's been this real explosion of single pair Ethernet standards development at the IEEE, as you said, over the last 7 or 8 years now. And the industry groups that have driven these various standards, initially for the shorter reach protocols, it was automotive driving 100 megabit, 1000 gigabit and beyond in order to deploy automotive Ethernet systems. 802.3cg that you mentioned was the standard that was primarily focused on building automation solutions with 10 megabits per second out to a kilometer. Now we're moving forward on multi-drop solutions, and that is still very early in development. I'd say we don't know exactly yet what the reach and the number of stations will be there, but you can keep your eye on that emerging over the next 3 to 4 years and becoming a ratified standard. And
then as long as we're on the topic of multi-drop, that's important in the building and industrial automation spaces, because as you know, with current bus topologies, you've got multiple sensor devices potentially that hook on a single bus, and to preserve the architecture, I think is a good objective that the IEEE is taking. So I think in terms of adoption, I think that's going to go a long way for this solution, the single pair Ethernet solutions, to be adopted in the automation markets, whether it's building automation or industrial automation. So it's a great progress that's being made by the committee.
Yeah, I think, Andy, that is especially important that they're working around sort of the existing design conventions for building automation systems and operational technology, because most of our buildings are existing, right? So 80% of remodels and refreshes are actually done in existing buildings. So if it's a brand new building, we can probably, we've got a clean slate, and we can design around traditional type of network architecture conventions, like that 100-meter rule, right? If we're starting fresh. But when we're going into existing buildings, we have to have a solution that is real world deployable, and I think that the standards are working hard to get to that point, so that we really can make it easier to transition from the old systems into the new systems. So we've kind of laid out what single pair Ethernet is, and it it looks like it's a thinner, younger version of 4 pair, but it's actually quite unique. And so I'm going to have Frank walk us through really how single pair Ethernet is different than 4 pair Ethernet.
Sure. Well, thank you. And part of the reason we wanted to put a slide up like this was that we're assuming that most people on this call are extremely familiar with the 4 pair type systems that are available. So it's always useful to kind of see those compared off to what is new here. And when you really think about what are we trying to do here, right? We're trying to essentially use single pair in new areas. Like a lot of times people ask me, do they think single pair would replace 4 pair? And I say absolutely not. I think that single pair will be in addition to 4-pair. It'll be really focused on a lot of systems that are not currently today using the 4-pair cabling for whatever reason. And some of those reasons can become somewhat evident by looking at this chart here. So on a 4-pair system, you can go fast. You can go up to 10 gigabits per second. With single pair, we really see a major application for it being that 10 megabits per second, but it's at 1,000 meters. So you see the reach on 4-pair is 100 meters. On single pair, it's going to be up to 1,000. So when you start looking at areas like on an industrial plant floor, in a warehouse, for some of these building automation systems, 100 meters can be very, very restrictive and somewhat limiting to how you might deploy a 4-pair system. Whereas going up to 1,000 meters on single pair will be very advantageous in terms of reach. Another area on it is power, right? So on 4-pair, you can do up to 71 watts on the latest PoE standards available. That's a lot of power. That can power a ton of devices. With single pair right now, we're saying 7 to 52, depending on cable length. So if you're at a short distance, you can maybe get up to that 52 watts. But when you're at that 1,000-meter reach, you're going to be limited to about 7 watts. And again, when you look at some of the things we're talking about deploying here, say sensors in areas, 7 watts is more than enough power to run a lot of sensors being deployed around the building. Another nice thing that we've looked at with single pair Ethernet is a connector type. So the RJ45, it's been what's used on 4-pair. It's a great connector. It's probably the most used interface in the world right now, and that's really ever been used, and it speaks to its success. And with single pair, we wanted to go with something that provides more density. So this single pair connector here, it's smaller. You can see the pictures there where we have them next to some coins. So it's about 50% more dense than the RJ45. And then rather than reinventing the wheel and trying a totally new type of connector approach, at least the type that's been adopted right now within TIA in the 42.7 group is a modified LC connector. So it's really based on another extremely widely deployed technology, the LC fiber connector module, except it does have some features on there to ensure that you cannot plug this single pair copper connector into a fiber LC port. So this is to kind of hopefully get some people calibrated here, and that single pair really is something new. It's something different. It provides, distinct advantages over existing 4-pair technologies in terms of density, in terms of length, and just really the fact that, we're already designing it to have, this basic data capability along with power, which we think for when you're looking at deploying sensors and a lot of these other devices is really going to be an attractive type of technology to use now for all these different systems. So,
Frank, thank you for that. The style of the connector, the LC style connector, there's a few things I really like about it and that I think are really important for the building automation market. And one is that, it's a field installable connector. So these don't have to be like ordered and pre-terminated cables with predetermined lengths, and so I think that was an important piece, that it's an easy termination process, repeatable. Also, one thing that we found through our design process at CommScope in developing our single pair Ethernet connection was there's things about the LC that consumers liked, and one was a confirmation click. And you don't really think about that much, but having a connector that clicks and you can feel it or hear it, but knowing that that connection is secure in place, that was actually one of the things that the audience was that they liked, they were interested in. They liked how that felt the form, fit, function standpoint. And so I think that this is a great connector. Also, the familiarity. If you've been in the network side, you're very familiar with an LC style type of connector. And so within single pair Ethernet, I think it's going to be that the plug itself will actually have more. It will be probably deployed more often, where in the field you're needing to put a plug on the end of the cable. So Now that's comparing it to 4-pair networks. So all of the, IT folks on the phone, that's your comparison, single pair to 4-pair. But Heath, can you tell for all the operational technology folks that are on the phone, how is single pair different than the existing 2-wire solutions that they're using today for their OT systems?
Yeah, absolutely. There is such a mix of protocols in use today. We saw the word chart earlier. A few years ago, I had the privilege of working for Bob Ray, who designed, at the time, the most successful 420 milliamp driver. This was a few decades ago on the market. 30 years later now, it's still best in class. So these old analog protocols have been around for a long time and continue to have some success in the market. But really, these protocols, especially the analog protocols like 420 milliamps or even UART, these are now quickly being replaced by modern digital protocols. And that's because the needs of the market have changed dramatically over the decades. And building automation solutions today, these are increasingly based in some form on Ethernet. In fact, many of the digital protocols have encroached on the term Ethernet. For example, there's Ethernet IP that has a capital N, Profinet, EtherCAT, just to name a few. So Ethernet has already begun this rather pervasive push into the building automation world. But what none of these standards offer is a fully 802.3 compliant 2-wire solution that will offer both the 10 megabit per second data and up to 52 watts of delivered power. And so this promise of TCP/IP stacks with 10 SPE combined with single pair power over Ethernet, that creates a reliable, it's an interoperable, it's a ubiquitous network for the IoT of tomorrow. When you think about the other protocols, typically you're either talking about a few kilobits per second. Very rarely is there power offered along with the protocols. So now when we get to launch forward to not only an Ethernet, not only TCP/IP, but the full 10 megabits per second of data and 52 watts of delivered power, it really enables the market, it enables new ideas, and it enables ubiquitous networks.
Thank you, Heath. That was a great explanation. And I get so excited at this idea that there's all of these different networks today. Some of them have power, some of them don't. Most of them don't provide power. Then that leaves either the designer or the field installer to kind of figure that out, right? And so I love that single pair Ethernet brings those two things together to really simplify this just for the installers. Another thing in some of our different interviews talking with building technology integrators and installers on the OT side is that they have so many different types of connectors. A lot of it is just two-wire cable, but there's different interfaces and plugs and outlets and terminals and things like that they're working with, and that means that they really have to understand a lot of different systems. So it's, especially if their expertise is really in the integration and bringing the systems together, or if you're a subject matter expert on mechanical systems, well, now you also have to be an expert on 10 different types of wiring schemas and termination styles, and so I think the simplification for the market from a field application standpoint is going to be huge. And having been in contracting for 8 years in my career, I can see where this could really make it easier for during the installation process and also from an industry training standpoint. So thank you for that. So we've talked about what single pair Ethernet is, and I want to cover more, and in each one of what single pair Ethernet is and covering the building automation market, a lot of this has already been revealed in our discussion so far, but we want to really dig in deep as to why single pair Ethernet is so important, and how it's going to have so much utility in the building space. And to kick that off, we're going to have Frank talk about the new Panduit World headquarters, because it is a great case study in the what could be, or how could we do this this better. And so, Frank, can you talk to us about your headquarters building?
Sure. So Panduit set out to build the most technically advanced headquarters we can, and really, make it a lead type of building, have converged systems in place. I mean, where I would sit, we would have, shades that would open and close depending on the light of, the ambient light coming in and everything. So we just really set out to build the best building we could. And as, Panduit is a provider of 4-pair cabling systems, we try to do as much as we could over, category 6A cabling. But, we ended up being limited because not everything can run over 4-pair cabling, right? There's a lot of systems that still required traditional 2-wire types of systems. I mean, our lighting systems and really just all the building control systems that we were using, there just weren't options available for us to use that 4-pair system. And so what that meant was we had to go with a 2-wire. And there are places in our building where you can actually see those 2-wire cabling systems running next to the 4-pair. That picture you see in the upper right-hand corner, the blue cable is category 6A 4-pair cables, and the orange cable there is the 2-wire systems. And we tried to do as much as we could off the 4-pair, but then we were limited, by running a significant number of systems off the 2-wire. And, it asked the questions, what could it have been? The building is still, very advanced, a great building. But again, it's, there has been challenges in terms of the integration side of it, in terms of getting all the systems to talk to each other, and just really, trying to take things, update them and get them to that next level over time. So, we do believe that by having a true IP-based system where everything is really running over the same language, could have just even been that much better. So it's one of the reasons why we are excited with single-pair Ethernet.
Yeah, no, that I think that this is really a great sort of case study of what's going on in the building with the cable, right? The fact that there is almost as much of this 2-wire cable as there is network cable really kind of, speaks to, we need to get this stuff on a common network, right? And I think one thing that we can't see in this picture is when it gets to all the end devices, how are they being powered? So that's like a whole other infrastructure that's having to be planned around these devices that are connecting to this 2-wire, where when you look at the blue cables, guess what? The power's considered.
True.
So I think that, and not for all devices, but any of the PoE enabled devices. And so I think that this really is a great demonstration of what the opportunity is and how we can do this better. We can do this so much better. All right. So thank you, Frank, for sharing that with us. Now, Andy, PoE has achieved broad and wide adoption since the original IEEE standard that was published in 2003. PoE is a technology that the market's familiar with. We're comfortable with it. There's a huge ecosystem of devices that have adopted PoE. How can single-pair Ethernet bring that same value to even more devices within the building, Andy?
Well, it's still Ethernet, and Ethernet is pretty ubiquitous, as we've already discussed. And this is really a poll that we did with building owners. This was commissioned by Navigant Research, but it really shows to the degree that PoE has really achieved that broad market adoption that we all want out of the Ethernet protocol. So, in terms of the advantages, common protocol, common wiring system to deliver data and power services has really tremendous advantages from an end user as well as an installer point of view. So you're not having to locally power stuff. You can centrally power stuff. You can put it back to a zone. You can put it back to your TR. There's a lot of advantages to it, but I think just the ubiquitous nature of Ethernet really is the key to success for single pair, because you're just leveraging on the success of what we've already achieved as an industry.
Yeah, I think that is true, right? We've got the Ethernet network and having that shared medium to be able to extend that to our operational technology devices is huge. I think that a lot of these operational technology devices and some of these new IoT type of devices, many of them currently today are equipped with battery technology, and certainly batteries are going to play a role within building operational technologies. But when you think about batteries at scale, and even the longer life batteries, when you consider the amount of sensors and devices that require power in the building, if you started, if they're all going to be on a battery technology and connect to the Wi-Fi network, what does that mean for maintenance, right? What does that mean for the real world operability or management of that building? And I think that when you start talking about a couple thousand sensors in a building with batteries in them that you have to do battery maintenance on, and you also have to figure out a way to ethically dispose of those batteries, that really is going to be a complication. And if a device is static, if it's not moving around, we should have a reliable power source. And another thing you talked about was, I think is really important, is a really important takeaway, is that just like how PoE is within the Ethernet networks, those network switches that are driving that PoE are connected into a reliable backed up power source. And so now we have, a lot of operational technology is critical infrastructure to the building's operation, and sometimes even impacts life safety. Do we want to leave that in the hands of batteries? Do we want our building operation in the hands of batteries? No, we want it on a reliable backed up power source. So I love drawing the similarities between the two. However, they're not exactly the same. Single pair PoE is different than PoE as we know it today. And Heath, I want you to talk with us a little bit about that.
Great, thanks. So some of this has been mentioned, but let me reiterate. So in 2003, that's when 802.3 AF, the initial version of Power over Ethernet, was ratified by the IEEE. And that standard was really being driven by voice over IP. There was a 911 mandate for battery backup, which meant that you either needed a battery in each and every phone, or what they discovered is it was far easier to achieve that battery backup by having a central UPS and PoE distribution of power. But the IT world, after this came out, quickly caught on to all the other myriad benefits of Power over Ethernet. So technicians can perform installation at a fraction the cost of adding an AC receptacle. There is interoperability between vendors. It just works. There is also far greater system telemetry, so you can get telemetry on what the system's actually doing in the power domain. The uptime of the system is greatly increased. You have port-to-port fault isolation, you have surge protection and ground loop isolation. All of these benefits arose after PoE got out into the world. Now in 2019, we've released the 802.3CG, the two-wire building automation focused version of single pair power over Ethernet. So we've already demonstrated that the benefits of smart power far outweigh the relatively small investments in the PoE controllers. Coming to the OT world now, we realize all the same benefits. One of the critical benefits here is that telemetry we talked about. A strong and secure network, a strong and secure system, it relies on device metrics, device health metrics. So even if in the data domain, a malveorant actor is attempting to spoof the operational status of the device, if you know what the power state of that device is, you can have a better knowledge that it is in the correct operational state at the moment. When we consider the difference between PoE and SPoE, PoE is delivered obviously over the 8-wire category 6, 7 cabling. This enables 71 watts, which is a function of the resistance of the cable, to be delivered up to a distance of 100 meters. Single pair power over Ethernet, on the other hand, delivers power over just that single pair of wires up to 1 kilometer. And that required a completely new approach to combining the power and the data. Two different power classes exist here. First, SPOE power can be delivered in a 50 to 58 volt range, very much like PoE. That enables a maximum power transfer of up to 52 watts. However, unique to SPOE, we also offer a low voltage applications in a 20 to 30 volt range, which allows the delivery of up to 8.4 watts. Both of these protocols, PoE and SPOE, they support classification. And what that does is it ensures power can be applied safely prior to the application of power, and that both ends of the cable are compatible. Both of these PoE protocols are safe and reliable power delivery mechanisms. They can take really great care in the deliberate application and removal of power. So we know these power systems are going to be subject to ever-increasing regulatory scrutiny. And as such, they need to be implemented in a rigorous and a standardized manner.
No, that is a great overview, Heath. Thank you. It looks like we have a lot of questions that are stacking up, and I love it. So keep the questions coming in. We will answer the questions at the end of the session, and it looks like we have questions that are coming from all different types of stakeholders within building technology. So looking forward to the Q&A section. Let's talk a little bit about simplified and standardized interfaces. And I think that any of us that are working in the corporate world, we understand how frustrating having all of these different types of connectors, even just to try to connect your Bluetooth iPhone headset to your corporate Dell issue laptop, right? I mean, the standardized interface, I think is an important issue. And I wanted to have Andy and Frank just, talk with us briefly about how important you think that this is for the industry, and Andy, especially because you're literally supporting so many different device manufacturers at Annixter, right? You're right in the thick of this, of all of these different endpoint device technologies. We'll have you talk about it as well. But Frank, starting with you, let's talk about simplified and standardized interfaces.
Sure. So in our view, having a simple and standardized interface is absolutely critical for adoption. I mean, one, to become standardized, say you look at what's the work that's been going on within the IEC or TR 42.7. You have a huge number of different companies come together and work on this, and everyone's bringing their areas of expertise to bear. So you have people looking at things like, how does the mating area work? Well, handle PoE, how do we plug this thing in and, people, ensure that it won't go into another LC connector? How do we provide strain relief on the cable? And you really see a lot of, just that knowledge coming to bear to ensure that you get a robust connector. I mean, I don't know how many people use Apple products, but, just having something like that lightning connector where, there can be dust that gets in the port that hurts it, or the strain relief on the back of it. I mean, I don't know how many of those things I've had to order online, but just having a connector that's been developed by a wide range of companies with a wide range of views really provides a very robust, mature, and reliable type of product. The other point I'll make on this is just by having a standardized interface, it's something that you don't need to worry about anymore, right? If you deploy sensors up into the ceiling, if you deploy this product anywhere, now that you'll have a standardized interface built to a standard that performs at a level. So say you want to upgrade from sensor 2.0 to sensor 3.0. All you'll need to do then is get that sensor, find where it is, plug the old one out, plug the new one in. And so it really just makes things simple and easy to use. And by having that non-proprietary interface, right, that standardized interface, you don't need to worry that, maybe somebody's going to go out of business, or this won't exist anymore, or maybe this vendor is going to raise the price on me because they've got me locked in, right? Having that standardization is just so critical. And we've seen it at Panduit for so long, just with the advantages of having an RJ45. can be. And that's why we feel very confident about single pair Ethernet.
Okay, thank you. Andy, your thoughts?
Yeah, not too much else to add. I think Frank covered the key points. I think, common physical interface certainly has benefits. We saw that with the RJ45 connector. That's again, the connector associated with copper-based Ethernet communications today. And it's often said that the RJ45 is really the only true global connector interface that's out there. If you look at power, there's multiple power standards around the world, multiple power interfaces, but RJ45 is that singular interface that you can use. And it was debated in TIA and the other committees as far as what the actual connector interface should be. And I think LC had some advantages in that it was pretty well adopted across the industry, although it was an optical connector. I think people are familiar with it, but the smaller form factor nature of the LC, I think, was really what drove, kind of the consensus to that connector type, at least for indoor office applications. So consolidating around a singular physical interface, I think, will really stimulate broad market adoption across device manufacturers. And I think once you have that, then you'll have, again, more of a uniform environment now that you can deploy your devices and your applications. So again, I'm just kind of echoing what Frank said. There's a lot of advantages to standardizing on a single interface.
Yeah, I completely agree, and think that those are excellent points. Frank said something that I hadn't actually thought about before, but it really does. When you have a connector where there is a consortium or a consensus or an ecosystem of people involved in the design of that connector, having all of that additional influence on the design and the reliability means a better connector. And I think that is, really with this LC connector, it was, multiple companies influencing the form, fit, and function. And so I think that it will provide that long-term reliability as well. So those are great points. Now, so there is the simplified and standard interfaces, right? But what about communication protocol? And Heath, I'm going to have you talk about this with our guest today. I'm having a little bit of a slide issue. Apologies. And talk about the communication protocols.
Sure. Now, I've already talked about some of the different communication protocols, the relative advantages of Ethernet a little bit. So what I'd like to do here is I'd like to share a story. So in this crazy era today of working remotely, our Santa Barbara lab, our PoE test systems over the last few months, they've really become this incredible rat's nest of ad hoc remote debug and control cabling. We're running I2C over UART, over USB, keeping all of that running error-free. It's not for the faint of heart, and frankly, it's not always successful. But I can tell you this, our Ethernet connections today, those form the bulk of our connected solutions for doing tasks remotely. We couldn't have dreamed of doing this even a few years ago. So all of these solutions range from remote controlled test measurement equipment to remote desktop platforms, and they enable us to be in the lab without being in the lab. So, without Ethernet in our lab today, my team would be at an absolute standstill. So the point of all this is that Ethernet allows us to focus our energy on our value-added applications, our value-added solutions, without getting lost in this forest of incompatible and esoteric protocols. So the promise of standardization for OT networks, it is the harmonization of the IT and the OT worlds. This brings vast economies of scale, unified control planes, and that allows us to meet the needs of the corporate tenants of tomorrow.
That is a really good real world story about how Ethernet really can change the landscape in the workspace. So thank you for sharing that story. I think one thing that comes to mind around this standardized communication protocol as well for me is security, device security. So, once we move things onto the Ethernet network, there are really good, well thought out security plans and processes and systems for Ethernet networks. And so, we know that device security is really important. We've all heard about all these different horror stories of how, X company was hacked through their mechanical system or this system, and really being able to move to a standardized process and implementation around device security, I think, is another advantage of moving to a uniform protocol. So now, another area that we want to talk about today is upskilling or training. The standardization of infrastructure, connectivity, and communication across multiple building systems, obviously has the potential to provide significant improvements in the design velocity and installation. Frank, you work with a network of installers every day, and that they install traditional network infrastructure, that 4-pair cable, right? Can you speak to what you feel are some of the benefits to that model of installation, and how the building automation market could benefit from a similar model?
Sure. So I'm assuming there's even a lot of people on this call right now that are very familiar with installing 4-pair cables. So we've got people that can design the systems, we've got people that install the systems, people that know how to terminate it. And then there's even organization, so we have an organization like TIA that writes the standards, organizations like BICSI that write even more detailed installation instructions. And what you really have is this, built-in network of people that are used to installing, standardized structured cabling solutions. And these solutions, they're installed with a very high quality, they're handled, they're neat, they're done to, industry-specific standards, both within TIA and BICSI. They're field tested, and then by and large, these systems are done to such a high level of quality that once these systems are put in place, people leave, and they don't typically need to come back, for maintenance. Like most of the cabling systems are designed to last over 25 years. So we believe that just by having this existing base of people that are familiar with installing stuff like traditional 4-pair systems, they could easily pick up the 1-pair types of systems and bring their knowledge to bear in installing these structured these very nice structured cabling solutions that can enable building automation.
Thank you, Frank. So Andy, you support a lot of different devices at Annixter. You guys are from the AV, operational technology, and security devices. Can you talk with us just about the upskilling and that knowledge transfer, the impact that 1-pair Ethernet could have on those device manufacturers?
Well, I think there's an educational period that has to happen. So I think we're at a stage now where we can approach a lot of these vendors with this technology. If you look at the commercial building space, the one use case and application that we're really looking at is physical security. So video surveillance cameras often exceed 100 meters in distance. So a lot of the solutions for extended reach that we use today, they're not as clean as what a 1-pair Ethernet solution could provide, because you're having to still provision power. Sometimes you have to use hybrid copper fiber cable to these. So to consolidate the physical interface, the 1-pair for physical security has a lot of advantages. So I think near-term surveillance solutions will be coming to the market. Long-term, I think more of the automation devices will start to come more online. But I think, as I pointed out earlier, the building automation industry, it moves a little bit slower, but I think they're taking steps to go to more of an open architecture environment. So I think the benefits of Ethernet and open architecture communications that are being developed within the building automation space, we'll see that start transferring as well. And we haven't really touched on the industrial applications, but I think we're getting a lot of interest from industrial customers. So folks that are deploying industrial I/O devices within, let's say, mining applications or factory floor operations, they'll see a benefit too as well. And I think if I were to bet on which market would move first, I would say industrial, and then we'll start seeing physical security, building automation devices come more online, probably early 2021. But certainly I think this year, industrial Ethernet, industrial automation, industrial IoT applications will probably be the primary beneficiary of the single pair Ethernet technology.
All right, thank you both. I think that there's probably lots of people on the line that are eager to learn more about how to design and deploy these systems. So we definitely want you guys to, everyone on the line, to stay tuned as the industry evolves these design guidelines and offers training. You can look to SPEC for that for sure. We're going to go to the Q&A session now, and so I'm going to ask that our panelists go ahead and switch on their cameras, and hopefully it's not actually allowing me to switch on my camera. We may have to do Q&A without video. We were going to give you guys some video of the panel, but it appears we're having some difficulty with that. That's okay. We can go ahead and get started with questions. There was a question on here about CECs, and so as you can see here on this slide, you can email Liz Goldsmith, and she will get you your BICSI CECs. And so we're going to start with some questions for the panel. And so one of the questions is, what LAN manufacturers are building single pair Ethernet switches and end device cards? And so maybe we could have Heath, do you want to cover that?
I'm sorry, I couldn't quite hear it. I had a little noise on the line. Can you repeat that?
Oh, sorry. So, yeah, what LAN manufacturers are building single pair Ethernet switches and end device cards for single pair?
So without divulging any information that's under NDA, I think you're going to see a mixture of the traditional large players deploying switches, as well as some of the system vendors. I do believe the desire in the fullness of time is to have the traditional switch vendors fill that niche in the ecosystem. Most of the system vendors prefer to focus on their end applications, on their value add. And so you are going to see emerging solutions from the large traditional switch vendors playing in the spaces that they best play in. Okay, no, that thank you. So, and it is a little bit early, right? We're in the standards development phase, and so we haven't had, that I'm aware of a major LAN manufacturer launch at this point, but it's in the works. So thank you for that. Here's another question, and I'm going to point this to Andy. Do we really think that buildings are going to double worldwide by 2060 when COVID has almost proven that we can work from home primarily?
Yeah, that's the question du jour. I think that that particular slide was made pre-COVID. I think that's a question that still has to resolve itself. I think as an industry, we have gone to the digital world fairly easily, but I would underestimate still the need for office space. I think there's still some jobs that you can't do remote, and I think to the degree that you can make your buildings more intelligent, there's still that desire to do that. Especially with some of the pre-healthcare screening solutions that we're seeing being deployed across commercial facilities. There's still a tremendous amount of interest around technology to deploy to make your commercial building spaces smarter. So it's kind of like a wait and see. We'll see how we as a society adapt, but I think commercial buildings will still be here. To what degree, I think, is anyone's guess at this point.
Well, and Andy, I could just chime in. Something I've been hearing is that there was already a trend kind of going on for, making building space more interactive, more collaborative. And so I think, you've kind of shown that, for jobs, for things where you can work individually, right? You might, working from home might be a good option. But, from the standpoint of personal interaction and personal collaboration, I haven't yet seen, online being able to take the ability to it. So, maybe it could lead towards smaller buildings, but I certainly still see the need for interaction.
Correct. And I think there's a lot of talk about multi-use buildings now. So, retail, office space, residential, these might become a little bit more popular because you're able to have these multi-use facilities that you could repurpose for multiple uses. So I think we'll see how the industry adapts, but it's certainly something that's on the forefront of all the commercial real estate folks that I've been speaking with.
Okay, all right.
I was expecting that question. It was a good one.
Yeah, COVID is definitely going to give us a new reality. I think, when we even looking though at the emerging global markets, there still is a lot that just has to be built right now. So there's definitely, I think we should still expect significant growth in this space globally. So here's another question, and I think that this is maybe really anyone on the panel, so I'll just have you guys jump in. Are there any plans to increase the data rates to 100 megabits?
There has been some talk about that at the IEEE. I think the focus right now is to complete the deployment of the 10 megabit systems. They have the greater reach, and then once we've come a little bit down that path, and we've also additionally made some headway in the multi-drop space, I think you will see a move to 100 megabit, where we'll probably be able to achieve something like 300 to 400 meters of reach.
I'll just say from the plumbing side, so on the structured cabling, the specs are category 6A. So the ability to move up to a higher data rate is there with the current specifications that have been proposed. And I think it's been shown that over even 2 wires, you can send gigabit data rates. So I think it's certainly possible to get that a higher data rate. But I think the focus is let's just get the adoption of the single pair objectives as they stand today, and we'll see where it goes.
Yeah, and I think a good point on should we transition to 100 megabits? And I think if the target for single pair Ethernet is these devices that are not currently Ethernet, then and if we think some of those devices have the need for 100 megabits, there's something there. We have a solution for devices today, right, that goes up to 10 gigabits. And so, and if you're a device manufacturer and you've already designed and engineered and worked through your supply chain, around 4-pair Ethernet or the RJ45, you have to ask yourself, why would I change away from that? I'm already getting all the benefits of Ethernet, and it's already designed into my device. So I think those are kind of important things to keep in the back of our mind, is that if it's already connected, what would be the reason to move it over to single pair from a device manufacturer standpoint? So it does look like there's lots of questions on availability for single pair Ethernet switches. And I think that he kind of already covered that it's in the works. We're early in the development right now, but you should definitely be, expecting to hear from manufacturers, I would say in the next 2 quarters, on the development of products. And then there is a question here: is there an interface at the far end to fit a device having an RJ45 IP connection? So.
If you're turning that one over to me, so it sounds like the question is, can you go, say, from an RJ45 to a single pair?
Yeah, yeah.
Right now, that would essentially be a very straightforward type of connection. So if you're going from a 4-pair to a single pair, you essentially have 4 single pairs on that system. I know people have, been looking at this. I think the term is called shared sheath. And I absolutely think this is going to be a way that things go forward on this at some point. But from the standpoint right now is that, my view of it is this would absolutely work. I would say initially not a primary focus of it, but something that, can absolutely should be able to be done.
So it would amaze you how much time we spent during the most recent round of POE development trying to work around some of the European cabling methods, which would take the Cat3 cable in that case, and it would split it at the wall jack and offer a telephone jack as well as an Ethernet jack. That created a lot of problems, frankly, for the deployment of higher power Ethernet. So while I think we will see some shared jacket deployments, I think the promise of the single pair Ethernet is really to have a simple, clean cable plant with well-defined point-to-point protocols for connecting devices.
Okay, and it looks like we have a question here, and it's actually a correction on our part. There was 75 billion and 75 million that were used interchangeably, and they want a clarification on that data point. It is 75 billion with a B devices that will be added to the network. Now, these are devices that are on the indoor and the outdoor network, and it is a global number. So obviously buildings have a high percentage of connected devices, but we also know that there's a lot of wireless and mobile technologies in the wide area network or in the outdoor space as well. So here is one. I will give this to Frank. What gauge is the single pair cable typically?
That is a good question. And so right now, single pair is not widely deployed. So I wouldn't say there is necessarily a common gauge to be used. But that being said, right now it looks like the standard will be anywhere from, say, an 18 gauge to a 26 gauge. And our estimation is that 18 gauge will be a common use case because that lets you go up to, I believe, about that full 1,000-meter range. Whereas the 23 gauge, we think could be another common use case because 23 gauge is a very popular gauge today. And that will allow you to go up to about, I think it's about 400 meters or so, which we think will be very sufficient for most applications. So we think those two gauge sizes will be the most popular.
Yeah, and I think that, the and I'm a lead green associate, and I'm always thinking about sustainability from and I think that where we can use the smaller gauge wire, we probably should. It's probably a more responsible decision, right? To be using less mined materials if that's possible. And so depending on how the building is designed, right? If you have these longer distances, like Frank said, you may need that 18 gauge. If it's a new building and you get to start from scratch, then you can probably design around the smaller cable because it's also going to be smaller, right? And easier to work with because it's a smaller gauge. So go ahead.
When you look at some of the existing building automation applications, they don't require a whole lot of data and they don't require a whole lot of power. So that's going to naturally lead you with 300 meters of reach. That's a lot of reach for most commercial buildings. And, the economies, the ease of installation, greater turn radius, that's going to bring a lot of benefits for the 24 gauge, 23 gauge cable.
Yeah, I agree. So when we look at single pair Ethernet, and if they're looking for industrial and covering indoor and outdoor and longer reach buildings, there usually is telecommunication rooms and equipment rooms, conveyances and such. So hopefully nobody actually has to run 1,000-meter cable run. That's a really long, complicated cable run. And of course, it might have interconnections in between, but the nice thing about the traditional standards is they make it pretty simple and straightforward how you can map out your infrastructure. Okay, this next question is interesting. I wouldn't even know where to begin to answer it. I am going to put this one on Heath. How does this technology handle the vibration and movement found in many building systems?
Handle the vibration and movement. Well, there was a lot of attention paid to signal integrity It's a primary concern of any Ethernet data deployment. Certainly the various types of noise, whether they're mechanical or electrical magnetic, can affect the integrity of your data. There's been a lot of attention paid to that, whether it's by shielded cabling or data integrity mechanisms. When we talk about just vibration itself, now you're talking about product design, and you're talking about connector design. You're talking about the value add that a given application might bring in order to be compatible with a certain type of application. And that often goes above and beyond the actual standards themselves, and might require the adoption of a vibration standard for the deployment. So I haven't studied the connectors, for example, but certainly these are all problems that have been solved in the traditional Ethernet world today, I believe.
And I'll just add one quick thing, because I know we're running out of time, but there's 3 specific levels for these connector and cable types. So these are using the MICE levels, if you're familiar with those. So the M in MICE is mechanical. So there's mechanical requirements that are there. And for MICE level 1, which is normal office spaces, as long as you're adhering to those requirements, I'm not sure if vibration is covered, but certainly if it's normal office environments, it should be fine. And if you've got industrial, there's MICE 2 and MICE 3 as well. But that's all been accommodated as part of the framework of the standard.
No, I think that's great. And even one maybe we could provide some additional backup to, or take back in and have a conversation in some of our standards groups around it, because definitely mechanical equipment, I could see vibration, sort of being an issue. And so I think that's a great question. So this last one, I'm just going to throw it out to the group. How will, and there's a lot more questions, guys, but in the essence of time, we will respond to each of your questions. Some of the questions were the same. So if they're redundant and we've already answered them, you probably won't get a direct response. But if we didn't answer your question today, then we will get these questions answered and out to the group. But the final question today is, how will this integrate with existing networks? Will Aruba, Cisco, and other vendors introduce modules to support this, or will we be stuck with a vendor switch between the edge and the devices?
Who wants to start?
Yeah, so it's hard to speak for the large network companies and their future product plans without getting in HIPAA trouble. But I think what I would suggest is to go look at the existing modularization and the existing industrial solutions that are offered by these vendors today, and to ask yourself how they are most likely to extend those solutions or expand those solutions. Tricky to go beyond that answer when we're talking about other people's product plans.
Yeah, I mean,
and I'll comment just if we use like the security industry as kind of a guide. The early cameras, when we were transitioning from analog to IP, actually had what we call hybrid interfaces. So they actually supported both, and that might be something that we're seeing. But we're talking to suppliers that are developing adapters that will allow you to adapt from single pair to a traditional RJ45. So this intermediate arena that we're in right now as we transition to the new physical interface, it'll be interesting to see what the device vendors come up with. But absolutely, I think there's going to be ultimately a cohesive ecosystem that we can deploy in the next several years. So it's pretty exciting times at this point.
And I think we'll see a mixture of closet-based switches as well as perhaps plenum-rated, where you can do kind of media expanders out in a more central location. So I think you'll find all of these solutions emerging over the fullness of time.
Yeah, and today, you have, like a building controller that maybe it has an Ethernet connection today back onto the network, and then from that controller, it's, running some form of a serial connection to the devices and sensors off of it. Certainly, manufacturers of those controllers could incorporate single pair Ethernet right into that controller. So I think it really is going to be
having those discussions, by the way, with different control vendors on that.
Oh, Yeah, no, and so I think it's going to evolve in probably a lot of different directions and be manufacturer specific. But there certainly isn't anything stopping anyone within the building automation to just incorporating it into their existing controllers and panels and things, the single pair Ethernet technology. So, and there, we'll have a standard, that MDI, that interface to the equipment will be standardized. The protocol will be standardized, but it could fit in any different shoebox, right? So, Frank, do you have any comments on that final question?
No, I mean, I think, between Andy and Heath, they really covered it as well. And it's some just speculation right now on our part, beyond the speculation we've already done here at some level. So, I think it was covered well.
Yeah, it's new technology, but with clearly a lot of utility for the building. That is all the time we have today for Q&A. We'll just kind of wave off to our before we move away from video, and we'll get ready to close here. If you're interested in joining SPEC, the Single Pair Ethernet Consortium, please visit our website. And if you want to learn more just about building automation in general, the organizations that are shown here are great resources to collaborate with other building technologies, and also just to gather more knowledge on building automation as a whole. I want to thank all of the guests today for spending this time with us. This is an exciting new technology. We are eager to get the word out into the market, and glad that you were able to spend some time with us today. And a sincere thanks to our panelists, Andy, Heath, and Frank. You guys bring a ton of experience and perspective to this topic. So thank you very much. Single pair Ethernet is transformative technology, guys. It's going to enable true convergence across all building systems. That's huge. Have a wonderful day.
Thank you.
Thanks.
Thanks all.